So in this lesson, I'm going to quantitatively describe equilibrium because we spent the last class working qualitative what exactly equilibrium means. Remember, it's when the rate of your forward reaction equals the rate of your reverse reaction. But now we're going to put a number to it. Okay? So the value that we use to describe the state of our equilibrium is called our equilibrium constant. All right? So as always, we can express equilibrium numerically, and we're going to do that with our equilibrium constant. So if I give you a generic reaction like the one you see below, what you will do to find your equilibrium constant, and we represent that with KEQ, okay? Your KEQ, your equilibrium constant, will be equal to the concentration, those brackets mean concentration, so the concentration of C, right, which one of your products, raised to its coefficient, which is the little c, times the concentration of D raised to its coefficient divided by your reactant. So the concentration of A raised to its coefficient times the concentration of B raised to its coefficient. Okay, so let's look at an example. So it says determine the value of the equilibrium constant for the reaction below. So it's N2O4 becomes 2NO2. And I give you the concentration of your reactant in your product. So all you need to do to find your KEQ is you're going to take the concentration of NO2 and you're going to square it because the coefficient for NO2 is a 2. And then you're going to divide that by the concentration of N2O4. Okay? So all you need to do now is plug in the values. So it's going to be 0.571 squared divided by the concentration of N2O4, which is 1.5 times 10 to the negative third. And so when you find your answer, it's 220. Okay, I rounded to two significant figures, so it's 220, and that's your answer. Now the question becomes, why exactly does KEQ matter? Why are we calculating that? Well, that lets us know what we have more of. Do we have more products, meaning our products favored, or do we have more reactants, our reactants favored? So before I go to the next slide, which breaks it down for you, if you think about it, you have products over reactants. So if you have more products than reactants, meaning your products are favored, that means your KEQ, your equilibrium constant, is going to be very large. It's going to be larger than 1. Okay? If you have more reactants than products, then that means your KEQ is going to be less than 1. It's going to be a fraction. So let's look at this. Here, if your KEQ, also called your KC, because we used concentration, if it's around 1, that means you have about equal amounts of reactants and products. Okay? If your KC is large, right, if it's much larger than 1, what that means is that your products are going to be favored, meaning that your reaction, the forward reaction, is essentially complete because the forward reaction proceeded to produce mostly products, meaning you have very little reactants left over. If your KC is very small, what that means is that you have more reactants than products, meaning your reactants are favored. So in this case, very little of the reaction actually took place because you have so much reactants when compared to products. So that's what your KC or your KEQ tells you. If it's really large, that means your reaction proceeded towards the product significantly, right? Your forward reaction did. If you have a very small KC, what that means is that very little of the reaction actually took place, meaning that your reactants are going to be favored. And if your KC or your KEQ is about 1, then that means you've got a kind of a typical reaction where your amount of reactants equals the amount of